Well, good day, y'all, and let us continue in our investigation of solutions in equilibrium. Let us jump right in here. It says consider calcium chloride dissolved in water and ethanol. Okay. Oh, two. I have calcium chloride dissolved in water, and I have ethanol dissolved in water. Okay, so I have two solutions here, right? So over here I have some water, right? And I'm going to have calcium chloride dissolved in water. And over here, I'm going to have some water, and I'm going to have my ethanol dissolved in water. Okay, good. Which solute is an electrolyte? Electrolyte. And identify the dissolved particles in each. Okay, so I think we need some new notes. Good. All right, so let's do a quick review. Here are my solutions, right? Here are my solutions, and we said over here that what is a solution? It's a uniform dispersal of one substance throughout another, right? Good, and we said there are two components to a solution. We have a solute and a solvent, and the solute is in lesser quantity and the solvent is in greater quantity, right? We said we have a process of solvation, and what is that process? Number one, we have to overcome intermolecular forces or attractive forces in solute. We have to overcome attractive forces in solvent. And then what happens? My solvent particles surround my solute particles, right? Good. And we said that if there's a special case, which is hydration, and hydration is solvation in water. When my process occurs in water, when water is my solvent, that is hydration. And then we talked yesterday, or not yesterday, last time, about characterizing solutions, right? And we said, hey, we can have a saturated solution. In a saturated solution, there is an equilibrium between my dissolved and undissolved solute. Okay, so saturated solution, I have both dissolved and undissolved solute present. And when I look at that, I can actually see precipitate, right? And then I could have an unsaturated solution. And in an unsaturated solution, there is insufficient solute to create a saturated solution. And then I have a supersaturated solution, and that's where I have more dissolved solute than in a saturated solution. And that sounds impossible. And what I have to do is I have to play some tricks, right? Like I might have to heat up my solution and then add lots of solute, and it'll dissolve at the higher temperature. And then I carefully cool it, and that precipitation won't start because it usually needs a seed crystal, and it doesn't have a seed crystal, so no precipitation occurs, and it's oversaturated or supersaturated. Good. Now this time we are talking about electrolytes. So what we want to do is add a new category, and we want to add this category, and we want to characterize our solutes. Okay, so we've characterized our solution. Now we want to characterize our solutes. And we want to characterize the solutes into two types. We want to have non-electrolytes and strong. Non-electrolytes and electrolytes. Electrolytes. Good. Now, remember, we're characterizing solutes. So what's a non-electrolyte? It is a solute which does not break down into ions when dissolved. Okay, that's a non-electrolyte. So that means the molecule stays whole. It doesn't break apart. And what are typical non-electrolytes? These are molecules. Most molecules are non-electrolytes. So if we have something like ethanol, C2H5OH, when that goes into water, we'll put water here, it stays C2H5OH. It doesn't break apart. So what I have as a solute, I have in solution. This is dissolved here, but it doesn't break apart. Okay? And so those are most molecules. Electrolytes, these are things which, it's a solute which breaks into ions when dissolved. Good. And the term that we use for breaking into ions, we call that dissociates. That means it breaks into ions. So we could say that, hey, solutes which dissociate when dissolved are electrolytes. And these guys are ionic compounds, strong acids, and weak acids. Okay, so those are my electrolytes. Good. I think we can answer our question. Here we go. Oops, wrong one. Where am I? Right here. Woohoo! Calcium chloride. All right, that's a solute. So now I have to identify, I have to determine whether calcium chloride is a molecule or an ion. Is that a molecule? No, this is what? This is a metal, non-metal. That means this is ionic. Ionic compounds are what? They are electrolytes. Electrolytes. Good. Ethanol? Well, ethanol we said is C. Let's draw the one possible picture of ethanol, right? That's ethanol. My organics are usually what? My organics are non-electrolytes. That is not an ionic compound. It's not a strong acid or a weak acid. So this is a non-electrolyte, which means when it goes into solution, when it dissolves, oops, it's over here, right? Sorry. Yoink. When it dissolves, what do we have over here? We only have C2H5OH. So identify the dissolved particles. Well, the dissolved particles for ethanol dissolving in water are just what? Ethanol. C2H5OH. That is what is dissolved. Now, what happens when my calcium chloride dissolves? Well, it's an electrolyte, so that means it breaks into ions. It's going to break into calcium 2 and chlorides, right? So what happens when I look in here? I get calcium and a couple chlorides, and I get a calcium 2 and a couple chlorides, calcium cation. So what particles are in this solution? Well, calcium 2 plus chloride, right? And so these are my dissolved particles. So really it'd be sufficient just to say my dissolved particles are calcium cation and chloride anion. Got it? Why is that? Because that's an electrolyte. All right, you guys give this one a shot. Well, you have an answer? Might help to know what methane is. So you guys can remember methane. Methane is CH4. Good. Now, is that ionic? No. Is that a strong base or a weak, strong acid or a weak acid? No. This is what? This is a molecule, and most molecules are what? Non-electrolytes. Why? What kind of letter is that? Electrolytes. Woo. Non-electrolytes. And what particles then would there be? Well, just CH4 is the only dissolved particle. It doesn't break apart, so all of the CH4 is dissolved. Good. What's my potassium? Potassium chloride KCl, well, that's ionic. So that means what? It's going to be an electrolyte. And what it will break into when it dissolves, or it will dissociate, and it will dissociate into K plus and Cl minus. Good? Excellent. Let's move on. A solution of chlorous acid, okay, that's an acid, and a solution of chloric acid, okay. If chlorous acid is a weak electrolyte and chloric acid is a strong electrolyte, identify the dissolved particles in each. I think we need some more information, and that would be correct. Okay, so where do we have to go? Is that it? Yep, there's our electrolytes. And we need to add some more under electrolytes. So here are my electrolytes. And we are going to break off electrolytes into two. We're going to break them off into strong electrolytes and weak electrolytes. Okay. Now, what's a strong electrolyte? A strong electrolyte is a solid which dissociates or breaks completely into ions. Okay, these are going to be my ionic compounds and my strong acids. Now, do you guys remember my strong acids? Well, we have H2SO4, and that's really kind of an exception. So we're going to leave H2SO4 out of this because it's a real weird dog. And in fact, we'll draw him as a weird dog. There he goes. Yoink, it big. Boy, he's had a lot to eat, a lot of sausages to eat. So although H2SO4 is a strong acid, it's strange, and we'll leave him alone and talk about him later. Good. But the strong acids, we need to know which are strong electrolytes are hydrochloric acid, hydrobromic acid, hydroiodic acid. What is this one? Nitric acid. What is this one? Chloric acid. And what is this one? Perchloric acid. So this is nitric, in case you've forgotten your naming, chloric, and perchloric. And what's interesting about these is when they dissolve in water, so we'll say that there's water here, okay, they will break entirely into their ions, just like an ionic compound would, okay? So that is a strong electrolyte. In a weak electrolyte, this is a solute in which an equilibrium, here's that word again, exists between the molecule and its ions when dissolved. Okay, that's a little strange, but if we look at it, we'll have a better idea. So let's take a typical weak electrolyte. And what are my weak electrolytes? Most commonly, my weak electrolytes are weak acids. Now, what are my weak acids? All acids except zoink. All acids except for my strong. So things like hydrofluoric acid, nitrous acid, chlorous acid, right? Hydrobromic acid. These are all weak acids. And what does it mean that an equilibrium exists between the molecule and its ions? Well, let's take HF. When HF dissolves, here I'm going to put it aqueous so we know that it dissolves. It breaks down this way. Now, what does this mean? Well, when HF goes into water, maybe we should draw a nice little picture. I like pictures. So here's water, and we're going to drop some HF in here. Good. Now, when HF actually goes into water, what happens? Well, some of the HF dissociates, and I have H plus and F minus floating around, okay? But not all of it. Some of my HF just hangs around as HF. And so when I look at what is dissolved, and these are all dissolved, when I looked at what is dissolved, all of this stuff is dissolved. Oops, all of this stuff is dissolved. And there then is an equilibrium, meaning some of my H plus and F minus are going to form HF while it's dissolved, while it's in the water. At the same time, some of my HF is breaking apart into H plus and F minus. And so we would say then, or we would draw this way, those double arrows suggesting that, hey, some of my HF is going this way to make H plus and F minus, and some of my H plus and F minus is going this way to make HF. Woo! But to summarize, what do I have in solution? All three. When I have a weak electrolyte, all three of its components are dissolved. The molecule, and then the ions which make up the molecule. Okay? Okay, good. Now I've simplified this a little bit. When we get into acid-base chemistry, we will get more into the details, but I think this is good enough for now. All right. Chlorous acid, HClO2. That is a weak acid. If it's a weak acid, what kind of an electrolyte is it? It is a weak electrolyte. Good. And what's going to happen in solution? Well, I'm going to have HClO2 plus, it's going to form an equilibrium between the H plus. Now, does the ClO2 break apart? No. This is a what? That's my polyatomic. That is my oxyanion. It's going to stay as an oxyanion. So these are the components that are in the solution when it dissolves. Good. Chloric acid, which is a strong acid, is going to be a one-way train to H plus and Cl3O minus chlorate. And so what is in solution? Hey, my arrow doesn't go in reverse. It doesn't go that way. Yoink, yoink. So that means all of this goes that way. And so what's left in solution when I analyze the solution? Only my hydrogen cation, or hydronium as you'll later learn, and my chlorate. Got it? All right. Let you guys do the next one. All right. What do you have to do here? First thing is we need to identify nitrous acid, HNO2. Good. Is that an electrolyte or a non-electrolyte? Well, it's an acid, so that means it's an electrolyte. Now we have to figure out, is it strong or weak? Well, what were my strongs? My strongs were HCl, HBr, HI, HNO3. Ah, there it is. No. That's HNO3. Okay, HClO3, HClO4, and then our strange dog. Give him big feet this time. Sulfuric acid. That looks more like a. I don't know what it looks like, but it's not a normal weak acid, a strong acid. It's a crazy strong acid. Good, but is HNO2 a strong acid? The answer is no. It is a weak acid. If it's a weak acid, that means it is a weak electrolyte. And if it's a weak electrolyte, that means the molecule HNO2 plus the hydrogen cation plus the nitrite are all in solution. So what solute particles are in solution? HNO2, H plus, and NO2 minus. Woo! Yahoo! Good. How many of you got a big smiley face in your work for me? Okay, well, folks, I think we want to quit right here. That's about 20 minutes. I think it's good enough. I will see you next time, and we'll get into the nature of solutes and solvents together. Ciao. Enjoy the day.